Wow, so cool.
Okay, so for the first question, it's asking about, oh, wait, hold on. Wrong group. I have so many tabs. It's asking about to find a factorial design research study, and the study that I found is called the effects of birth origin and gender on the attachment scores of Hispanic adults. And I will put the citation there. So each factor, so the two factors were birth origin, and the levels are to native born versus immigrant. And the gender is female versus male. These are quasi-independent variables because you cannot manipulate them. They're fixed. And this was a between subjects study because there were 4 different groups. And the main effects were basically, there was only one significant interaction being affected by birth origin, and that affected the score of dependency. And according to the adjusted and non-adjusted group means, there were no significant main effects between all the mean scores. So the results of the study show that no significant group differences between birth origin and the scores of close, depend, or anxiety were present. So there were no group differences for gender and the scores of the 3 dependent variables, and there was no significant group differences for birth origin and the 3 dependent variables. However, the results did show immigrant births showed higher levels of closeness and dependency and equal scores for anxiety with the independent variable of native birth origin. And they showed there was no significant factor interaction between gender and birth order and gender and closeness. There was an increased score for closeness and anxiety for male gender and increasedness and dependency for female gender. So at the end, the researchers determined that there was no support for their research hypothesis. And that's it for my number 4.
It seems pretty straightforward to me. I'm not gonna lie. I didn't really find anything that I can add.
Yeah, I wasn't sure how detailed to go in with the results, like, because he's like described the results of the variables, and I can just go on and just go really into detail. So I might rewrite this section and make it a little bit more comprehensible. But I just kind of like wrote everything right now, so that's why it sounds a little disjointed. So
I think you got like the main ideas though.
okay, great, thanks.
Okay, I can move on to mine. All right, so for mine, this one kind of took me a while. I was kind of confused for a bit. I had to reread and reread. But anyways, in figure 11.5, we show 3 combinations of main effects and interactions for 2x2 factorial designs using the same 2x2 structure with factor A defining the rows and factor B defining the columns, create a set of means and produce each of the following patterns. So basically they give you, or they provide us with guess a different equation and you have to build a graph. So before I get started, I did kind of have trouble with the tables. I couldn't get like the I don't know if you all have the screen there. I couldn't get the mean, the M equals, on the sides of the tables. So I kind of just, I don't know if you all know how to how to work that. Feel free to show me or something. And yeah,
Okay.
I don't know. I couldn't get it on Google Docs. But anyways, where are my notes? Because I don't know if you all saw the graphs itself. It gives you the M equals, inside the table, and then there's a factor B on the top, a factor A. I couldn't get the design well.
Oh, you mean like the labels?
The labels, yeah, exactly.
Oh, okay. Maybe
Yeah,
you
I
can just
couldn't.
add insert row above.
You can put factor B above, and then on the left hand there's like factor A. I don't know if
Yeah, because you want it to just be like in the middle, right?
right. Yeah.
Okay. Yeah.
So the labeling of things was kind of difficult for me, and I think it was mainly, and I didn't even think about it. Maybe later on I can go on to like Word and do it on Word, because I think I know how to do it on Word, where I can label everything perfectly and then just copy and paste and hope it translates well for the graphs. But
Yeah.
So anyways, I can get started. I just want to let you all know that I couldn't really get the design how I wanted to, or the labeling how I wanted to. But so for factor A, let me get my notes here. We have a set of, we need a set of means that there is a main effect for both A and B, and there is no interaction. So I put 20, 40, 30, 50, as y'all can see. The overall mean for the first row of factor A is M equals 25. The second would be overall M equals 45. And then the first overall mean for row B is 30, and the next one is 40. So we see that the marginal values for factor A are 25 and 45, which shows the main factor. Oh, I'm reading the wrong one. Sorry. So I put 20, 40, 30, 50 there. A is indicated by the 10-point mean difference between the rows. So that means there is a main effect for A, and then B is indicated by the 20-point difference between the columns, meaning there's a main effect there. There's a constant 10-point difference throughout. This signifies no interaction. So that's A. For B, a main effect for A and an interaction, but no main effect for B. So I put the numbers in the box there: 20, M equals 20, 50, 30, 40, as you all can see. The overall means for factors A are 25 and 45, which signifies a main factor for A. And then values for factor B overall is M equals 35. So there's a consistent mean there, which signifies no effect because both of them equal M equals 35. There is an increase from one level of A from 20 to 30. Then there's a decrease from 50 to 40, concluding that there is a significant interaction. So if you draw out the graph, because of that, they will cross and signify interaction. And then C is main effect for both factors and an interaction. So factor A, the overall means was 20, 25 and 50, which qualified, for concluding there's a main effect. And then for factor B, it was 40 and 35. Also concluding that there's a significant main effect. There's also a difference in values in B, an increase from 20 to 30 in one row of A, and a decrease from 60 to 40 in another row or level of A, concluding that there is an interaction effect. Again, should I include the graphs? I don't think the graphs are necessary. I don't know if you all saw read that part in the book. There's like these line graphs that they add to show interaction. I can include them, but I don't know if they're necessary.
I don't think it's necessary if it doesn't, if the question doesn't ask you to include the graph, then I'm sure it's fine without it.
Okay. Yeah, that's what I figured too. And I know sometimes if y'all didn't, kind of glanced over the section a little bit, the numbers sound weird. And I know I was like reading on the docs, like, different numbers that weren't exactly on the page. And that was part of the labeling that I couldn't get the labeling how I wanted to. So that's something I'm going to try and figure out here on Microsoft Word and then copy and paste.
Yeah. I mean, yeah, I think it's kind of also, if you don't manage to get the labels, it's sort of self-explanatory. But yeah.
Yeah, I think him like reading it, like if I read it, since I really focus on this section, I know what I'm talking about. But if someone didn't read it, they'd be like, what is he talking about? Where are these numbers coming from? But someone that read and knows, the section, I think they'll know what I'm talking about. But I'll still try it just in case.
Yeah.
We
Okay.
can even, I'm pretty sure we can even, I don't know if you have the book online, but I feel like we can screenshot it and like put a picture, but I think Professor Ali would probably have an idea of it since the questions are on there.
Yeah.
But yeah, that's it for me.
All right.
Okay, I'm next. I got chapter 12, the first question, and it was just saying, it gave us like a list to talk, kind of like several variables that change like among college students. And it said, select one variable from the list and then think of a second variable. It could be on the list or like my own that should positively relate to the one I selected. And then briefly describe how you would do a correlational study. I decided to do like hours of sleep per night. And then one of my own that I put was academic performance. So I put, if students are receiving enough hours of sleep per night, like quality sleep, then it is likely they will perform better on motor tasks and with memorization, resulting in better GPA scores in comparison with students who are sleep deprived. So basically saying that they're both positively correlated. And then I went into detail a little bit about what a correlation study is. And I put that to go about the correlational study in a college classroom, researchers can gather GPA scores and ask around how many hours of sleep they typically get at night. It could be like in a survey or something. And then they will likely be positively correlated. Therefore, as hours of sleep increase, it is likely that so will the GPA. So that's, I don't know if you guys have any suggestions, or I was wondering if I should include that the researchers should gather the data through a survey, or like should I just leave it like, I feel like it's a little bit like should I go into detail about that or no?
I don't know if a survey is necessary. Let's see. Yeah, I think that just gathering the GPA scores is good.
Okay.
Yeah.
All right, sounds good. And then they also gave me one, like it was the same question, but this time it was negatively related. So I just chose alcohol consumption and among college students and the relationship with academic performance once again. And I put, I was reading like some research articles, like trying to figure out which ones to pick. And there was some studies that said that alcohol could possibly reduce numbers committed to students studying, attending school, and overall like have negative associations with motivation. These were like just a couple factors. So with that being said, I just put these two variables are negatively related in the sense that there will be a change in opposite directions for the two. So for example, if students are intaking high levels of alcohol, then their academic will decrease. So I put a correlational study can be carried out to establish a relationship among factors described. So researchers can carry out studies in a college classroom and gather their academic data, then ask students in a survey around how much alcohol they consume. But I'm probably going to change that into like just gather data. to not be so specific, to kind of like leave it up to the researcher. And I put from there, researchers can determine whether a relationship among the two exists. And that's it for me.
Sounds good to me.
Sounds good for me too. For me, it says select one of your correlational studies from activity 1 and describe how the same relationship could be examined during a non-experimental differential research study. So I went back to activity 1 because I definitely forgot everything about activity 1. And to get back into it, it was basically just comparing like kids like respect towards their like reading level and their leisure activities. So I chose our first like research goal, and it was older and younger children's respect level towards reading as a leisure activity and its relationship to other options that could compete with reading. So the authors combined like 6th and 9th graders, so that was like a number of 25, and conducted surveys to see if there was a relationship with their reading and other leisure activities. So the results showed that like their reading level wasn't like as popular as like other stuff, but it wasn't like their least popular activities. It was very moderate. So in order to make it to a differential research study, I created 2 groups, which I separated the older children and the younger children, or the younger adolescents. So basically split apart the 6th and the 9th graders, and then seeing if there was a difference with like their age group level and their respect towards their reading and in comparison to the other leisure options. And that was like really it. I really did not know if I should like go more in depth just because I didn't conduct research. So I don't know what would be the change, but I could read in the article again to see if there's like, if there was like other, if they did split apart the statistics and discuss if there's like a positive or negative relationship and see if there was like actual difference. But other than that, I think I'm good.
Yeah, it looks good to me. No, I mean, I don't really have suggestions for it.
Yeah, I think it sounds good to me.
Yeah, I read the book and it was just saying like the only difference between like correlational and differential is that differential normally uses like groups and compares between like 2 groups to see that there's a difference, and correlational really just does it in more of a totality. So I kind of just split it between age groups.
Yeah, right. It's just trying to find a difference between the age groups
Mm-hmm.
rather than finding a relationship.
Mm-hmm.
Okay. Yeah, that makes sense to me.
For sure.
Okay. Great job, everyone.